Okay, last section, 1.8 on inverse functions. Oh, stop doing that. Thanks. Okay, so before I talk about these things in the box here, let's go ahead and start with example. I'm just going to jump straight to example 1. I did as a video. It should be in Schoology. It's part of the homework. So, okay, so let's take a look at. You need a pencil? Okay. So when you do an inverse, okay, this is an inverse. What you do, guys, quiet please. You switch x and y. Okay, that's all you do in the inverse. You simply switch x and y. So what I'm going to do is going to swap all the x and y coordinates. So these tables, sorry, these columns switch. So -3, 0, -1, 1, 0, 2, 2, 3. So what I'll do is let me plot f of x in red. So 0, -3 down here. 1, -1 right here. 2, 0 right here. And 3, 2 right here. Now let me do the other ones in green. -3, 0, -1, 1, 0, 2, and 2, 3. Now this is the part that gets the interesting observation that you should take note of. And actually, I just messed that one up. Hold on. That was synchronous. Okay. This pink line here, in a way, acts as a line of symmetry, right? So if you think about it, if I were to cut out, like if you actually took a pair of scissors, cut the square piece of paper out, folded that square piece along this diagonal, this point would map onto that point. That point would map onto that point. Thank you. That point would map on that point, and so forth. Is that your question?
No, I think that point's too high.
Oh, did I make? Oh, yeah, I made it too high. No, you are 100% correct. That's way too high. Thank you for noticing that. There you go. Yeah, because it didn't look symmetric. I totally agree. So what happens is that when you have inverse functions are always symmetric to the original function along y equals x. That's always going to be true for inverse functions. They're always symmetric to the original function along y equals x. But algebraically, you're just swapping x and y. That's all you're doing.
What is it? Over y equals x?
Along y equals x. Yeah. So let's do it again for example 2. I'll leave the screen where it is. So if you're still copying some, let me move this around. Oh, let me try again. Okay, so let's look at the next one here. Let's go dark green. So again, just swapping the coordinates, right? -1, 0, -1, 1, 0, 2, 2, 3. So -1, 0 is right. Shoot, I didn't move the screen. Let's do it again. My bad. All right, so -1, 0, -1, 1, 0, 2. JP, put the phone away. 2, 3. Okay. So let me do the inverse in dark green. 0, 2, 2, 3. And then let me do the original in red. 0, -1, 1, -1, 2, 0, and 3, 2. And let me draw a pink line. So you see how the green and red points are symmetric about y equals x? Yeah. So again, you have symmetry here, right?
If think the messenger is so much easier than the.
Greg, what do you mean actual?
I'm gonna be homophobic.
Oh, but then the homework is harder? Okay, it's good to know. All right, let's try this again, guys. Actually, let me, I'll come back to the top of the first page when I'm done. All right. Okay, so we know what this means, right? This means f of g of x. We also know what this means. This means g of f of x. Actually, I'm just rewriting it. So what you have to do is you have to replace x here with where g is.
Okay, so then when you have g of x, you find g of x and then whatever that is.
I'm sorry, repeat that, please.
Find g of x and then whatever that is.
Yes, right, right. So in this case, I'm going to put 12 plus 4x. Right, because I replaced the x in that next equation with where g is, right? So I replace this x with where g is. So it becomes 12 plus 4x. Now clean it up. We clean it up, what do you get? Good. And what? Keep cleaning it up, please. Just plain old x. Interesting, we see that. Let's do it again for b. Now in this case, you're going to go the other direction, right? Now, now what you're going to do is you're going to replace the x with f of x.
So you just plug in for like the 1/4 x minus 3, you just plug in for like 1/4 x.
Yes, yes, 100%, 100%. Oh, that's hard to read. Let's go light green. Distribute this guy, you get 12 plus x minus 12. You get x again. When this happens, I'll put the text box up above. When f of g of x equals x and g of f of x equals x, then f and g are inverses of each other. They'll always be true. You could find them. You guys remember how to find the inverses of functions? How to do that? So you switch x and y, and you isolate y. So if I were to, let me erase the stuff down below. So I know stuff for f of x, I switch x and y, right? Now what if I isolate y? What happens? Get this, multiply 4, what do you get next? What was that equation I just got? Is it the same thing as g? Yep, there we go. So we know that works. So the inverse composition rule says that a function is of f is 1 to 1 with the inverse function g if and only if actually, not sure what's meant by that. Every x in domain of g. I'm not sure what's meant by that. Let's just cross that off. That just seems weird to me. The bottom line is this: f of g of x equals g of f of x, which equals x. Okay, so let's try it now for example 4. Are these inverses of each other? So you could do this a couple ways. Let's say I find f of g of x. Let's do that. So instead of x minus 2 over 5, what am I going to put in the parentheses here? Exactly. So you get 5 over x plus 2 minus 2. Oh. All over 5. So you get 5 over x. And the 5 by itself, you could think of 5 over 1, right? Any whole number could be a fraction. with one at the bottom. How do you divide fractions? You guys remember? Yep. So, or times 1/5. Now what happens to the 5s? Where are you stuck with? So we didn't get plain old x. So in this case, the answer is no. Not inverses of each other.
Wait, what is the negative x?
Where do you get negative x from?
What is x? Oh, 1/x.
1/x, right?
That's the same as negative.
No, it's actually -1 power.
Oh.
Totally different thing. But regardless, we didn't get x as the final answer. So that's why it's no. Yeah, no, not inverses of each other. If you did g of f of x, same thing, you would not get x. So. Okay, let's now actually practice finding inverses, and then we'll wrap up these notes. I do need to go back to the top of the previous page, of the first page of these notes. All right, let's look at here. Remember, example 5. So f of x equals 1/x minus 4. Find the inverse. So all you do is you switch x and y. Then isolate y. That's all. That's all. Then isolate y. So fx is y. If it helps, put a y there. So you switch it, right? Now this is where the algebra comes into play. How do I isolate y? How do I do it?
Multiply by switch by y over 4.
I mean y minus 4.
Yeah.
Okay. Good.
And then divide by x.
Yeah, so then you got this y minus 4. So y minus 4 equals 1/x. And then lastly, add 4 to both sides. So this is the inverse of the original function. Or we like to write like this with a little -1 symbol. Same thing. That's just inverse function notation. No, it's all part of the same problem. I just don't have space. But yeah, if you put f -1x, it's the same thing as inverse. So that's just inverse notation. So that should be pretty easy. Right?
The inverse doesn't exist.
That's a great question. Yeah, don't worry about that. I'm not gonna ask that. Don't worry about it. Great question though, because I'm not 100% sure. I think it probably would that would happen if you can't isolate y. And I think if you were to get actually, I'll show you. You know, I do know what it means. I lied. So Charlotte, if you have something like this here, like let's say y x squared plus x, right? We switch x and y. See how y occurs twice? I can't really isolate y here.
Yeah.
So the inverse would not exist. More specifically, what's happening is that the original function is a parabola, and it fails the horizontal line test. That's another reason why too. But yeah, but I'm going to talk about that at the end of these notes. Okay, next one. What do I do first? Switch x and y, right? So the thing is y, fx is y, so it's -2y squared plus 1. Okay, let's begin isolating. How do I isolate? -1 for both sides. Keep going. Good. We're almost there. Same thing. No. Yeah, you gotta put plus or minus. So that'd be your inverse there. However, this would fail the vertical line test because y equals 2 different numbers, and you can't have that for a function. But for now, let's just worry about isolating y, and that's what you do. Okay, lastly, for example 7.
Can you keep that on the screen? We're just-
Sure, I'll pump the brakes.
I have a bad throw about today.
Well, a second before I don't care. Yeah, so I dropped my son off at school yesterday because he starts school a little later. And I checked my phone. I see, what was that? Oh, he's in kindergarten. Yeah. Yeah, sorry. But anyway, after I drop by, I checked the Furman and Virginia score. I see Virginia's up by like, I think 3 points. So, okay, I got this. I'm okay. And then I just like look at the last seconds, like, you gotta be kidding me. And then I picked up both my kids from school. And I look at the Arizona score, and I see Prince of Arizona, and I let out like a 4-letter word. My kids in earshot. So like I knew I was done at that point. I was like, hey, I'm done this tournament. So,
SC lost.
SC lost, we know that. But to Michigan State, right? Yeah. That was a foregone conclusion. All right, let's find these inverses here.
They're up by 5.
Oh, that's cube. I'm sorry. Hold on. My bad. My apologies. That's 3y cube.
You have to do plus or minus for a cube root.
No, just square root. Because square root could hold 2 different values. That's why. It's actually all even roots, Charlotte. That's what you do. Can we divide by 3?
What's good?
So y equals the cube root. So that's going to be f negative 1x. Does that make sense, guys?
So just solve them each individually first.
Yeah, unfortunately, you have to. There's no
And
shortcut.
then combine them?
Then plug in net 4 in each one.
I'm plugging what, each one?
4.
Oh.
Well, not each. Well, hold on. Let's hold off on that. Let's hold on to that thought. Okay, here you're going to let x equal 1/8 y.
Then you just multiply by 8, right?
Yeah, x plus 3 equals 1/8 y.
Yeah.
8x plus 24 is 50.
Good. Excellent. Thank you, Charlotte. So then that's going to be the inverse of g, right? Yeah, 8x plus 24. Okay. Now, what do we really want? And let me erase this stuff up here. We don't need this anymore. I have a select tool. Why am I doing that? That takes too long. There you go. All right, so now what does the question really want? It really wants g negative 1, f negative 1 of 4. So you got to plug 4 into the inverse, which will be the cube root.
And then you're plugging that number in for x.
Yeah, totally. Totally. Yes. So that'll be 1. And if you plug 1 into the g inverse function, that's 8 plus 24, which of course is 32.
Wait, so you don't plug in 4 to the g function?
No, because it's going to be the output that you need to plug into the g function.
Wait, can you do that again?
Sure. So I'll walk you guys through it. So the red is the inverse of f, right?
Yeah.
So I'm going to do all that to get that. Blue is the inverse of g, do all that, right? So then what you do is you have to plug 4 to the inverse of f first, because the inverse of f is closest, right? You always go with what's closest. That's a composite. Because here there's an open circle in the middle, right? It's not times, it's composite. So this means you got to plug 4 into f, and then that has to go into g.
So
When
with the
I plug
outcome
4,
you get,
if I plug 4 in the inverse of f, I got 1. Okay. And then then I plug that into the inverse of g. And I do that, and I got 32. So this is just review of inverses from algebra 2, obviously. Something we will need for the next unit. Let me go back to the top of these notes here just to wrap it up. So horizontal line test. The inverse of a relation is a function if and only if each horizontal line intersects graph of the original and at most one point. So for example, if you have like this here, the inverse will be a function because horizontal line test passes just once. But if I have this here, like a parabola, for example, how many times the horizontal line passes this graph? So in this case, the inverse is not a function. That's a horizontal line test. A function be one-to-one means it passes both vertical and horizontal line test. One-to-one. So such a function's inverse is also a function is one-to-one since every x is paired with unique y and every y is paired with unique x. And if a function is one-to-one domain range, an inverse function denoted as this is a function domain R. So domain range switch, just so you know, for inverses.
So whatever the domain is goes to the right, it would be.
Yep. Compared to the original function. And I'm not sure what's meant by the statement below. Defined by, yeah, I'm not sure what's meant by that. I'm just gonna cross it off. But the one thing you do need, the domain range are switched for inverses compared to the original function. For inverses, they will get switched, as they should, because x and y are switched. There are some loose ends I'll need to tie up on Tuesday regarding this unit, which is better I do on Tuesday. So if you guys, and I do have a practice set. I'm not gonna make it due because I think you guys have a lot to get caught up on. I'll give it to you guys anyway. And I'll update Schoology. But I'll give you guys this if you guys want to practice on 1.8. It has the answers too. Homework quiz is already ready to go. It's password enabled. So what you want to do to get there, let me stop recording.